Start by connecting the USB and power cables on the back of your Daisy-Solve valve instrument. And then turn it on. On the hardware side, decide which ports you will not be using and plug them finger tight with our port plugs. Excessive over-tightening may damage the threads of your manifold as well as your port plugs, so be careful. For the ports that you will be using, we recommend click and seal fittings that click and slip once the ideal tightening torque has been reached, thereby preventing any damage to your system. If you use any other type of fittings, once again make sure they are only finger tight. If you will be testing the instrument manually, you may connect a syringe to one of the common ports. You can test each valve's connection manually. Here, we use blue-colored distilled water to demonstrate. On the Daisy controller software, click Refresh Instrument List to detect your module. Select it from the drop-down list to enable the virtual instrument panel on the center top of the window. Real-time control button enables manual control of each valve in real time. You can also select valves and use Open Selected Valves button to activate them simultaneously. The valves in Daisy-Solve valve are normally closed. Activating a valve opens it, connecting that fluidic port to the common port. Finally, Close All Valves button turns off all active valves. Switching from manual to automated operation is simple. Click Edit Assay File button to start editing a script. Choose Append Above Parameters button to see the command format for the manual settings chosen in the panel above. Every automation script starts with defining an interface with the modules using self.myInterface. Each instrument chain that has a USB connection to the controller computer is part of the interface and appears as a group. In this case, we have a single USB connected instrument, so there is one group. When directly connected to USB, Daisy-Solve valve module is in the first instrument group, in other words, groups 0. And it is the first instrument of the group, in other words, inst 0. Now that the instrument's position in the chain is defined, we can proceed with automation. Valves can be activated by the command turn on valves, with valve numbers specified inside curly braces that denote a set. In this example, we are creating a simple loop that cycles through all 8 valves sequentially, keeping each one on for 1 second before moving on to the next in the sequence. All valves are closed with turn off valves command. When done editing the script, you may save it before running. As your script runs in the assay window, the lines being executed are highlighted for your convenience. This also helps in debugging. We recommend flushing all flow lines with 70% IPA or ethanol solution at the end of each experiment. This should be followed by flushing with distilled or deionized water, which can then be followed with a clean air flush. Don't leave any buffers or other salt-containing solutions inside your Daisy-Solve valve. When dried, such solutions leave salt crystals behind, which can then clog or damage your manifold and valves. If other instruments, such as pumps, were used in the chain, it is best to clean the entire fluidic path all at once. At the end of cleaning, you may turn off your instrument and remove power and communication cables. After flushing with air, fittings and tubings may stay connected to the manifold or removed and stored separately.